In this lesson, we will look at the definition of function composition and discuss the domain of composite functions. Definition. Suppose f and g are two functions. The composite of g with f, denoted g composed with f, g open circle f, is defined by the formula g composed with f of x equals g of f of x, provided x is an element of the domain of f and f of x is an element of the domain of g. Recall that a function f matches an x value in the domain of f with a value f of x in the range of f. A function g may match that value of f of x with a value g of f of x. G of f of x is equivalent to g composed with f of x. Note that g of f of x is in the range of g composed with f. The domain of g composed with f may be different than the domain of f. We'll next look at the domain of g composed with f. The domain of g composed with f. If g of f of x is in the range of g composed with f, there is some value f of x in the range of f that is matched with g of f of x. But there may be some values in the range of f that are not in the domain of g, so would not be matched with any values in the range of g composed with f. This limits the x values that are matched with g of f of x to those that are in the domain of f and those for which f of x is in the domain of g. The white area within the domain of f is the domain of g composed with f. As an example, say f of x equals x plus 1 and g of x equals square root of x. And let's say we have an x value of 3 and an x value of negative 2 in the domain of f. And let's see what happens with these. F of 3 is equal to 3 plus 1 or 4, and g of 4, g of f of x here, would be the square root of 4 or 2. So we're fine there. What about negative 2? Well, negative 2 plus 1 is negative 1. That's fine. But when we go to finding the square root of negative 1, that's not a real number. So I figured out here that negative 2 should actually be in the domain of f, but not in the domain of g composed with f. The domain of g composed with f includes values of x that are in the domain of f and for which f of x is in the domain of g. Let's find the domain of g composed with f of x, where f of x equals x plus 1 and g of x equals square root of x. So we'll start by finding the domain of our inner function f. Remember, g composed with f of x is the same as g of f of x. And I want to start by finding the domain of f of x. Well, the domain of f of x here is all real numbers. And then I want to make sure that f of x is in the domain of g. So what do I need to be in the domain of g here? I need for f of x to be greater than or equal to 0. And that means that x plus 1 needs to be greater than or equal to 0, or that x needs to be greater than or equal to negative 1. Okay, so the intersection of these two domains is going to tell me that the domain of g composed with f will need to include values of x greater than or equal to negative 1 and would then be square bracket negative 1 comma infinity. All values of x greater than or equal to negative 1. The domain of f composed with g, where f of x equals 2x plus 5 and g of x equals 2 over x plus 3. Let's see if we can figure this out. Well, we don't have g composed with f here. We have f composed with g. So here, this is the same as f of g of x. I still start with my innermost function, and I want to look for the domain of g of x this time. So the domain of g of x, I will have all x values included except negative 3. And then I want to make sure that g of x is in the domain of f. And so to do that, well, f of x is equal to 2 times x plus 5. I can put any value of x into f and have it be okay. So whatever value I come up with as my g of x, I can put into f of x. So the domain of f composed with g here will be all values except -3, the intersection of these two domains. And so it would be -infinity to -3 union -3 to infinity. Try on your own. Find the domain of f composed with g of x for f of x equals x minus 3 and g of x equals the square root of x plus 1.